The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Thermodynamics. Conservation of energy law. Energy is neither created nor destroyed. It is only converted from one form to the other. And the first law of thermodynamics states that the internal energy of an isolated system is constant. So let's take a little bit of a deeper look at the first law of thermodynamics on the next slide. Okay, great. So say we have our system here, right? And we'll just put some surroundings down here. Great. Actually, let me just write system here one more time. So it'll make sense in just a second. And we have surroundings here. Okay, great. Here's our system, and we'll say this is our surroundings. System and surroundings. We just said that the internal energy of an isolated system is constant. If the internal energy of an isolated system is constant, yet now it wants to exchange energy with its surroundings, it can do so through two processes. One is it can do so through heat, and the second way is through work. Okay, wonderful. If the system loses energy, then we're going to have a value of less than 0. Great. Therefore, if the system loses heat, right, our value is going to be negative. If the system does work, then our value is going to be negative once again. Okay, great. So then what would happen if the energy enters the system? Then the values would be flipped, and if heat goes into the system from the surroundings, then the heat value is going to be positive. If work or heat is absorbed by the system, and if work is done on the system, then the value is going to be positive. Great. And the values here, they're going to be greater than 0. The idea here and all the signs that we've basically just shown can be put into one expression, and that expression is the internal energy equation, which says change in internal energy equals heat plus work. Wonderful. Now let's move to our next slide and take a look at an example of this. Okay, so example, first law of thermodynamics. What would be the internal energy of a confined gas in a system that does 300 joules of work and expands to absorb 30 joules of heat? So again, it's asking us for the internal energy, so we can go ahead and write in our equation. Perfect. Heat plus work. Now let's take a look here. It's saying that our system is absorbing 30 joules of heat. And if we take a look back at our one slide back, we just said if the system absorbs heat, it's going to be positive. So we can go ahead and write in positive 30 joules. Great. Next, it says that the system does 300 joules of work. So now let's go back at our slide, and we see here when the system does work, it's actually going to be negative. We can go ahead and write in a value of negative 300 joules. Wonderful. Once you go ahead and you equate this, you'll end up with a value of negative 270 joules. Therefore, our system has lost 270 joules of energy. Okay, wonderful. Now we're ready to move on to our next slide. The second law of thermodynamics.